Hi, I'm Tommy.
I'm Derek,
And I'm Ryan.
and welcome to
Good Karma Bikes.
I want to ride my bicycle. I want to ride my bike. I want to ride my bicycle. I want to ride it where I like.
Good Karma Bikes is a non-profit social enterprise located in San Jose, California. The company works with the organizations shown at the bottom of this slide, such as AAA and Cisco, to receive donations and grants that go towards full services and social outreach programs. There are three types of bikes that Good Karma offers to the community. The first are donation bikes, which are bikes that are good only for its parts. These donation bikes are stripped down and the parts are collected into the shop's inventory. The second type of bikes are program bikes. These bikes are in relatively okay condition but are in need of servicing. Typically, volunteers working at Good Karma would service these bikes. Once they are fixed and quality assured, these bikes are sent out to social outreach programs to help out homeless and at-risk foster youths. The last type of bikes are shop bikes. These bikes are refurbished and fully serviced by staff workers with the intent of putting them up for sale. These bikes are sold at an average of $200 and Good Karma spends roughly $10 to $60 on maintenance and parts. Currently, these shop bikes bring in about 40% of the company's revenue. Good Karma has an ongoing mission to positively impact those in need. One of their major goals is to increase their revenue from $400,000 a year to $2 to $3 million. This increase would help them expand their service programs to benefit those in need in a more profound way. They desire to focus their outreach towards disadvantaged youths, specifically those who were former foster care children, and provide them with work readiness and college entrance. In order to achieve this objective, our senior project group will focus on increasing storage capacity for bikes and standardizing procedures for new incoming volunteers.
Now that we understand Good Karma Bike's history and goals as a nonprofit organization, they have asked us to tackle some problems that would help them steer in the right direction of achieving those goals. The problems are listed within this problem statement. This past year, Good Karma Bike's inventory of parts and bikes have steadily increased due to their growing reputation in the San Jose area. Due to this increase, bikes start to become misplaced and stripped parts are being mislabeled, then thrown into random piles. In addition, inexperienced volunteers forget procedures on how to repair bikes and store parts in their proper place, causing staff members to leave their work to provide extra assistance. This problem results in an increase in backlog on customers' orders. So from this problem statement, the problems that need to be addressed are the storage of bikes and parts throughout the shop, and the decrease in productivity from staff members due to retraining their volunteers.
This is the current state facility layout at Good Karma Bikes. The top left space shown on the layout consists of 8 workstations for staff members and volunteers to fix or strip down bikes. There are cabinets consisting of new parts and other equipment in close proximity of that area. However, tires, derailleurs, chains, brakes, and the majority of other spare parts are located at the bottom left area. In this current state, bikes are placed on racks that are categorized by the type of bikes. As shown on the right, floor and customer bikes along with bikes in need of quality check are placed closest to the workstations, whereas program and donor bikes are placed farther. The top right space consists of the designated rest area, where workers can take breaks and relax. This location is also used for tutorial video demonstrations for new volunteers in need of assistance. The space below the rest area is dedicated to admin and offices.
This spaghetti diagram demonstrates the movements by the staff members during our observation in a 2-hour period. The red line represents staff 1 and the green line represents staff 2. And the majority of the movements were walking from the workstations to the cabinets in the bottom left area to retrieve parts.
Good Karma Bikes currently has 2 different bike racks being utilized at the facility. The main bike rack is a green and white picket fence, which can fit up to 10 bikes max for each rack. The dimensions of this rack are 66 inches wide with bikes placed on it, and 93 inches for the small size, and 99 inches long for the larger size. The gaps for the tire are between 2.75 inches to 4.75 inches, which allows room for a bike to lean over, taking up more space. In addition, handlebars need to be 15 to 18 inches long when lined up next to each other, because the handlebars are preventing bikes from being pulled off the racks because they're too close in space between each other. The total amount of green and white bike racks are about 9 in the warehouse, and the second bike rack is a brown one, and the size of this is 60 inches wide with the bikes placed on it and 64 inches long, and there's only one of these brown racks being utilized in the warehouse. The limitations for this new bike rack design needs to be that the materials need to be low in cost, and that there's no vertical design, and it needs to allow bikes to be easily accessible, and last, it needs to decrease the amount of square footage within the warehouse. And to the right are 2 literature review designs that we researched, and one of them would utilize the space, but however there's a vertical design to it, so therefore the employees do not want to be lifting 30-pound bikes up to place it onto these racks. And the one below is a pole system where the mechanism is lifted up along a ramp in order to be hooked on. And this would be a high materials cost in order to make this, so therefore we did not go with that. Therefore, the new bike rack design that we came up with is a combination of 2 already existing designs. One of them being the bike racks that are at Cal Poly's campus, designed by Peak Racks, and another one is a website that we found that shows how to make a do-it-yourself bike rack. And therefore, we designed this bike rack through SolidWorks, and it has a staggered design to it. Therefore, that allows bikes to be easily moved in and out of the bike racks. And with this design, it can hold up to 14 bikes total.
This new layout includes the addition of the new bike racks, as well as moving the cabinets from the bottom left area to the top left area. This would reduce the distance traveled from 33 feet to 20 feet each way when retrieving a part.
Some secondary impacts that can occur with our project are an organizational impact, meaning that before there was no set procedure on how to place bikes on the bike racks, but in order to utilize this new design, the employees and volunteers will have to position the bikes in a proper way in order to get the max efficiency out of these bike racks. And the other impact is an environmental one, because the bike racks require a large sum of lumber in order to produce it.
The performance metrics used to justify the new designs and changes we made in Good Karma Bikes facility and bike racks are as followed. The first one being space utilization, which is used to determine the number of bikes processed per square feet and a number of bikes stored per square feet. The second metric was distance traveled, which is used to determine the amount of waste in terms of unnecessary motion and how typical that is in the process of fixing bikes and stripping down bikes. The third performance metric was productivity, or the number of bikes fixed or stripped per labor hour accomplished by either a staff member or a volunteer.
Throughout our project, we will be applying multiple IE classes to design a solution for the problems. We will be using IME 223 process improvement through the use of spaghetti diagrams, process flow maps, 5S, and also we'll be using IME 443 facility layout through working with the program Microsoft Visio, And also we'll be using IME 319, Human Factors Engineering, IME 429, Ergonomics, and also IME 140, SolidWorks, which is our 3D modeling so we can help with the redesign of the bike racks. Thank you for listening to our presentation. If you have any questions, please feel free to email rpogan@calpoly.edu. Thank you.